Go.
Go. All right. Hi, everybody. Welcome to another episode of Continuous Discussions, the online forum where we talk about Agile, DevOps, and continuous delivery. I'm Sam Fell.
And I'm Andreas Wallgren. Today's topic is continuous monitoring. In DevOps, monitoring should be ubiquitous. To ensure uptime, optimize user experience, and business impact, you need to continuously monitor your applications, your infrastructure, look for security vulnerabilities, check your logs, as well as checking the delivery pipeline itself and all of your release milestones. So we're going to talk today about how monitoring has evolved for DevOps. And as we shift left monitoring, out of production and into the software pipeline itself, what are some of the patterns and tips to keep in mind to take our reliability and incident management to the next level? As always, we have a wonderful set of panelists.
Fantastic. We do have a wonderful set of panelists, a lot of folks who have joined us before. Andi, Mann, say hello to the folks out there.
Hello to the folks out there. This is Andi. I'm from Splunk. Great to see you all.
Wonderful. Thanks for joining us. Andreas, welcome back.
Hey, thank you. Thanks for having me back. Hopefully you can hear me. My background is not as colorful and beautiful as Andi Mann's. It's more like boring, but still.
That's how we can tell the two Andys apart.
Yeah.
Right. Mark Burgess, welcome.
Hello.
Tell us a little bit about yourself, Mark.
Today I'm in blue. I was the founder of CF Engine years ago, and now I'm an independent consultant talking about all kinds of different things from monitoring to cloud and configuration management, I guess, is what I'm best known for, but I do a lot of other stuff as well.
Wonderful. Well, we're happy that you were able to join us. Torsten, welcome to the program.
Hey, good afternoon, Sam. Thanks for having me. I'm Torsten Volk. I run the practice for hybrid cloud containers and cognitive computing at Enterprise Management Associates. And monitoring really is everywhere on all the different levels. So I'm excited to be here today.
Wonderful. We're excited to have you as well. Paul, welcome back.
Yeah, it's great to be back. It's been a number of episodes. I'm super excited to be here.
Very cool. And Paul was having some trouble on the hotel Wi-Fi, so he may be on and off of his video for a little bit.
We'll see if this works.
That's right. And so if you're not on the panel but you want to be heard, go ahead and join us on Twitter. C9D9 is the hashtag, and we'll try and get your comments into the program. Let's go ahead and get started. We've got a lot of smart people on the panel, and Anders, I'm including you in that as well, to talk about monitoring and how it's changing for DevOps. So what are some of the architecture things that you need to think about and some of the prerequisites that you need to have in place in order to be able to do effective monitoring in a DevOps sort of practice? And I'm going to just go ahead and start. Let's turn off my thing here. Who's up? Andreas Grabner, you're up on the screen, so why don't you go ahead and start first?
Sure. Yeah. So I think what at least we are seeing, DevOps promotes technology of choice. Basically, selected technology that allows you to solve your problem, and don't let the technology that you have dictate how to solve which problems. So I think I like this, right? Choose the technology that helps you solve the problem, but then it means we have a lot of technologies that come into organizations. Old ones, enterprise stack, new ones, new stack in the cloud, in containers. And all of these tools and technologies, they bring kind of their own set of monitoring tools with it. But what we see, and this is, I believe, why all the monitoring vendors, including Dynatrace, try to promote full stack monitoring, all of your stack, all of your components, because otherwise you have serverless monitoring here, your logging here, your Java monitoring here, some infrastructure monitoring here, and nothing really fits together. You have a lot of data silos that you can then have to kind of magically kind of make sense of. So I believe when you're talking about architecturing new applications, you need to figure out how to, what your monitoring strategy is. How can you monitor all of the different moving pieces and components, whatever technology it is, in a good way, so that in the end you can make sense out of it. Right, that's, I believe, the challenge. Think about monitoring right from the start.
Interesting. And so when you're thinking about architecting of the application, you're thinking about telemetry of how to get information around the pool sizes and the Or are you
Well,
also
not only that. I think it starts with how can you monitor the success of the feature that you're pushing through, right? It starts with how can we measure if the stuff that I'm actually pushing through is actually used, and then how well does it run? Because if we deliver something that is very popular, but then it's very inefficient, then how can you monitor the resource consumption? And how can you monitor if you have any problems with your configuration? Because that makes it slow. So I think you have to figure out how can you measure success of software they put out there, but also the resource efficiency, if it's correctly deployed, and if we have any bottlenecks. I think you have to cover all of it, not just pool size. Pool size is one aspect that is relevant and important for certain groups of people around the DevOps toolchain.
excellent? All right, very good. Mark, what are your thoughts on monitoring prerequisites?
The picture you painted is so huge, right? I mean, today you could think of monitoring, if you think of the whole pipeline from the developer to operations, you've got all of those tests that include software testing, semantic testing, unit testing, acceptance testing, et cetera, et cetera. And then you've got the runtime behavior of the software as well. And that's usually where I start, because my background is more on the operations side. And my expertise, I suppose, is more in this sort of scalability side of things as well. So to try to keep it a bit narrow, I would say that the key challenge in monitoring is really understanding scale. You know, we tend to design software on a single laptop, and then we deploy it onto some kind of a scalable platform where all of the assumptions and prerequisites are changed, and the architecture is even different once you deploy it in some elastic scaling regime and so on. And this brings up new issues that you didn't necessarily confront when you designed the software, or you were led down a certain route by the technology or the cloud that you used. You know, did you use containers? Did you use virtual machines? What were the specifics of that? What we've become very good at doing, because of the attention that's been focused on development, you know, developers have risen in importance in this discussion versus the operations people. Because of that, we've seen that a lot of the tools for containing software have developed significantly. So we've gone from physical hosts to VMs to containers, and now possibly even unikernels. And we're shrinking the surface area of this software considerably, with many practical consequences. One of which is, how do you monitor your way out of that paper bag that you've wrapped this software into? And so actually, all of the traditional approaches that we've used for monitoring, probing, putting agents on systems and so on to spy on them, all of these things are sort of changing and in flux. And what I think is important and is often forgotten in discussions about monitoring, or two things actually. One is that your monitoring system has to scale in a similar way to the way your software scales if you want to see, get useful data out of it. The other thing is you also need to be somewhat selective about what you're looking at. I still see a lot of examples of people simply watching CPU and memory consumption, regardless of what they're doing. They're still using basically PS or these old X monitoring things with their Athena graphics have been now, re-implemented on the web with no more sophistication or interpretation added. So we're still looking at, through an incredibly primitive telescope, at software which of increasing complexity and trying to make sense of it. And I think perhaps the biggest challenge we have is that we don't have the skills people don't have the training to use the tools to get the answers to the questions they need to answer from monitoring.
Very, very interesting. All right. Let's see. Torsten, I'm sure you have some thoughts on this. I saw you nodding your head viciously.
Yeah. I mean, the scalability concept is critical, and then there is also the single pane of glass concept, just as critical. Our research shows that struggling when they, for example, adopt containers or DevOps automation, any kind of new technologies, serverless computing, all of those things that promise so much impact, business impact and agility. And there's this whole notion of the digital attacker, right? That I want to turn my shoe store even into a digital attacker. Everything needs to become a digital attacker. But to get this done, the monitoring software has to be wrapped into the life cycle, right? It has to be deployed, has to think about monitoring, just like they have to think about backup and high availability. It is basically a part of the deployment package, a part of the infrastructure. And what I especially like, not to say that Tosca patterns are coming back, but I see in general this abstraction of the application from the underlying infrastructure as a positive new development where, we've had this for a decade where we said, I have to deploy to any cloud. I deploy based on blueprints, right? Dynamic Ops before they were bought by VMware already said that. But I can see finally that we have so many clouds and so much technology and customers using TensorFlow at Google and something else at Amazon, and they're basically cherry picking the best services from everywhere that they like the most. The pressure has really become tremendous to put these patterns, deployment patterns, back into place as an abstraction layer between app and infrastructure. And part of those deployment packages has to be the monitoring solution. And a lot of research data that shows that management and monitoring silos are the main factor that are holding back customers from going further with containers and with any of those new infrastructures, right? Because it's nice to run it on a laptop, right? I like that analogy, right? I can do it too. I have it on Docker on my laptop and I can run anything. But if I had now to deploy it, or if somebody were to take it from my laptop and deploy it, I don't have any instruction on scalability or on policies or on compliance or any of those things wrapped into my container. That there's nothing there, right? I just got the thing to run and I was happy with that. So this end-to-end thought of making the monitoring a part of whatever you push out as a microservice or as a web app or as any other kind of app, and then making sure that you fully understand all the individual layers from the LAN all the way up to the business service. That is the key that our main focus area is in North America, but that's the key that our research really shows: a single pane of glass monitoring and across the board, make it part of the DevOps deployment process, and then of course also having this abstraction of the application from the underlying infrastructure, and not falling back into that trap of point solutions. So that's, in a very long statement, actually, my take, what we are seeing.
Yeah, but it's I think that's right on. I like the idea of making sure that you're not that paper bag that you talk about, right? That the more we abstract, that's fantastic for flexibility and agility and all these other things, but visibility then starts to, you're sort of putting an opaque lens on top of it. Andi, Mann, what are your thoughts on this? One EMA guy to another.
A former EMA guy.
Is he coming back?
It's really interesting. I think you need to look at the multiple vectors of monitoring and think about DevOps from a systems thinking point of view. Then you start to use those systems to understand what you're monitoring. I thought Mark was really spot on talking about component monitoring and speeds and feeds and servers and switches. And this sort of stuff is still really important, of course. But thinking about these systems thinking, you start to look at whole services, end-to-end services, like Torsten was saying, looking at all the bits and pieces, the multiple cloud components that make it up. You might be using some serverless components, some on-premises components, God forbid. So you need to have this system thinking, and there's multiple systems in play. So you think about the application service, the service that you're actually writing to deliver to your end user, to your customer, to your internal user. You think about the dev services. So touching on, is my development service actually working properly? The tools that are essential for me as a developer to be able to create code and deliver it? Are they all working well? You think about also things like my pre-prod or staging environment as a service. You know, I think you need to monitor that. Your pre-prod environment is actually a proper replica of your prod environment for that QA and performance testing and all that sort of stuff. So when you think about these different systems, it's very much a change in the way that you approach the software development through this systems thinking, but that obviously affects monitoring. And then you start to think about shifting that left, and that becomes a whole different ball of wax. Building application monitoring into your application. So then we could talk about things like semantic logging and other things that are really important to be able to understand the action of the application, not least so that you can support it. So again, thinking DevOps and monitoring, you build it, you run it. So you know, you have to think about all of those different systems. I think that's probably where I'd start.
All right. So I'm just typing back and forth with Paul, who has just rejoined us. Thank you, Andi. That's obviously very interesting. The system level thinking, it's very DevOps of you to pull that one out. I think that's super important to look at the big picture, but also, as you mentioned, as Mark mentioned, to have that sort of your eyeball on the little picture as well. All those component atomic bits, all the atoms need to be working well for me to be functioning. And if I have a temperature, then you might not see it inside the atoms, but I'll be able to tell you about it. So Paul, you're back, and I guess you've got better bandwidth now. What are your thoughts on architectures and prerequisites for monitoring for DevOps?
Yes, I've sacrificed to the hotel Wi-Fi gods. So one of the things that I kind of always, and this is probably not a surprise to anyone that sort of looks at or listens to talks that I give, is I like, especially with monitoring, to think about actually what aviation does. And so, you know, when you look at, I make the comparison to black boxes, right? And the interesting thing about, you know, black boxes is that they encode the infrastructure. So like in aviation, we might talk about like the planes, so the engine and fuel and all that kind of stuff. They also, you know, record information about the environment, so like airspeed and altitude. And then they also record the operational aspect. So that's like the cockpit voice recorder. So the point is that monitoring is not just let's throw some agents on, you know, on our infrastructure, on our nodes. Let's, you know, maybe instrument our application. Really, monitoring includes a number of different aspects. And I think a lot of times because, you know, we're how many years into DevOps and monitoring is still so nascent, in lots of cases, you know, we find when we look at the incident lifecycle, you know, the first part of it is how do you get notified about incidents? In so many organizations, it's like, oh, we hear from our customer service that the website is down.
The CEO's wife will send us an email.
Yep, exactly. So point being is that you know, I tend to look at this space a lot through incidents and remediation and that sort of lens of it. And perhaps unsurprisingly, monitoring permeates all of that as well. And you can see sort of, you know, where your monitoring deficiencies might be actually by looking at how do you find out about it, you know, incidents, right? And then when you're doing retrospectives, like what parts are missing from those conversations. And again, a lot of it can be just ignoring the operational aspect that we also need to be monitoring, as well as the environmental aspect, and then the infrastructure aspect.
Right, and the best usage of a black box is after you've landed to just delete it. Yeah, that's the best thing, is when you don't actually need any of those data points.
Yes,
best thing. Anders, what are your thoughts on architectures and prerequisites for monitoring?
Yeah, I mean, you know, I think you know, it's a sort of a trite thing to say at this point, but you know, architecture really matters, and we found that out, I think. Very much so in the last 2 or 3 or maybe 5 years, as we start to think about things like microservices and loosely coupled architectures and those types of things, and monitoring should be thought of as part of the architecture. You can't bolt it on after you've deployed your application. It's, if you do that, then you're going to be kind of hamstrung in what you can do, and you might be kind of constrained at that point to as you were just saying, sort of monitoring the atoms, which won't necessarily tell you have a fever. And I think the other thing that's kind of interesting about the whole monitoring problem is that it's metrics, right? It is one of the hugest source of metrics that we have. And so we need to think about what is it that we're monitoring for. CPU usage, that isn't necessarily interesting, right? What we want to monitor for is outcomes.
Right.
Was the customer successful in doing what they wanted to do? If not, can the monitoring, help tell us why, right? Because we don't want to monitor just for performance and load and those kinds of things. We want to monitor for how long did it take them to find the right button to click, and all of the kinds of things that in days past we would have thought about as sort of usability testing and those kinds of things. And I think we have a very rich set of primitives that we can use now for doing kind of higher level type monitoring. And the last thing I'll just sort of say is shift the monitoring left. It makes no sense to just monitor in production. You should be monitoring while you're testing. You should be monitoring throughout your entire software pipeline, if possible. Now, people may say, oh, we can't afford that. Those Dynatrace licenses are pretty expensive. Sorry, Andreas. But you really have to think about it. What's the expense of that versus the expense of a problem that you encounter only in production that would have shown up, during your pre-production testing.
And in addition to that, sort of to pile onto that statement, is when you do find something into production, if you have devs who are familiar with that tooling, with those monitoring, they understand it.
Good point. Yeah.
Much faster you're going to get to resolution.
Yeah.
It's interesting, Andrew. Something you said reminds me of that old adage that data is not the same as information, and metrics are data, right?
Yeah.
And you're talking about you want to get to a higher order about information about how we interact with our operating system and run that system and respond to it when it's in crisis, incident context.
Yeah.
And
Mark, did you have something?
Also rolls into the whole signal to noise ratio thing,
Yep.
which we have to worry about as well.
Yep.
Yeah. Mark, did you have a comment?
Yeah, I wanted to come back to something that Paul mentioned. I thought he made a great point, which is that we shouldn't be just looking inside software, but also looking outside. I distinguish between interior and exterior promises in my sort of way of system thinking. And the interesting thing about all of the new container levels and abstraction levels that we're dealing with is that what used to be inside is now outside. What used to be interior monitoring is now exterior monitoring. What used to become part of our software is now part of the environment. And this is continuously evolving, especially when we look at microservices. So you start out with a cluster of processes, it becomes a container, a cluster of containers, a VM, cluster of VMs is a physical host, cluster of physical hosts is a subnet, cluster of subnets is a cloud or something like this. And at each level, this dichotomy, if you like, between what's interior and what's exterior causes us pain because we have to integrate those viewpoints and try to understand where causation is based. And of course, the microservices question has totally blown up this issue and shown how our monitoring systems are totally inadequate, really, to monitor the kinds of systems that we're building now, the architectures that we're building. We're still, to use a bad analogy, we're still doing CPU and memory things, which is like kind of taking my pulse to see if I'm giving a good talk. The level of insight you get from that simple heartbeat monitoring is trivial and almost nonsensical. Mm-hmm. People will invest a lot of time and effort in doing heartbeats, but we still have to crack that challenge of integrating the viewpoints of interior and exterior influences on software and what that actually means to the entire system.
I love it. And on that note, let's switch topics and let's talk about what to monitor, how, and why. I think that inside versus outside comment is super germane as we start to make things opaque through abstraction. And we grow systems on top of systems. What used to be an atom, or what used to be a system, is now an atom for some other bigger system. So how do you wrap your head around this? And Anders gave some insight already, is you should start as far left as you can. But what other types of things should we do? And I'll actually start with Andy Mann this time. Andy? You're muted. You're muted, Andy. You can't hear me, perhaps.
There we go. No, I'm better. Sorry about that. Yeah, I got muted. I was probably chatting to myself. So I'm a big fan of service monitoring. So looking at the entire service, yeah, we reorganize teams in a DevOps mode and agile mode. We're starting to see certainly people reorganizing teams into sort of product teams or mission teams. And I think that the monitoring needs to go along with that. You know, if I'm part of the accounts receivable team, or if I'm part of the web UI team, you know, I want to be monitoring what I'm concerned with, but I want to be monitoring all of the components within that service. So if my service is, order entry, accounts receivable, my service is the online store, for example, then I want to start with monitoring the individual components. So wire data, obviously I would say log data, you know, inputs from APM, you know, storage. Yeah, and you do need to, I think, still monitor CPU and server and storage and IO and throughput and all those good things. But you need to tie them all together. So you're monitoring, what is my service? How do my customers respond? Are they getting the service they want? Is this, you know, achievable? And so the impact that you were talking about, Sam, I think is really important as well. Am I getting throughput in my website? Are customers signing on, signing off? Am I getting cart fulfillment rates or cart abandonment rates above the normal KPI? And so understanding this end-to-end service, this is part of the systems thinking as well. So I think there's, yes, low-level component monitoring, but then you need to start monitoring as well the impact that's having on the end customer and look at it all holistically. I think it was Torsten who said that one screen of glass. Go.
Now sounds muted.
Yeah, I was muted that time. I think I muted myself because I've learned over the years it's the best thing for me. So let's see. Torsten, what are your thoughts on this?
So that's entirely right. I love that analogy, by the way, about measuring the pulse in terms of trying to deduce the quality of somebody's ability to talk or to you know, expertise in a certain topic. That's exactly right. And that's what Andy was mentioning, and it's a big part of the story. The other big part of the story is to connect this APM element. How does the application serve the customer with the underlying infrastructure monitoring element, where maybe there is something broken in my infrastructure, right? I have red lights, I have a network throughput issue, somebody, you know, something is not right, but how much should I actually care as the systems admin, right? How much should I care as the IT operations team about this issue versus 10 other competing issues? Where should I spend my time on? Or say resources are tied, right? I get orange lights and then, oh, wow, this is not going to be good. But what is lacking today is that connection between the business priorities on the top and at the bottom, the individual engineers that are fixing the problems, right? They don't really know. Maybe we want to expand in India, right? So our user experience is key. So I have two red lights competing, but I usually don't know which one is the red light that affects the Indian customers versus you know, whoever else that I may not as much care about as a company CEO or board of directors. So very important to get this top-down approach, this top-down monitoring view where I can say, here's what's going on that is relevant to my business problem from an infrastructure perspective versus, you know, here's people violating best practices. What do I care if they violate best practices? Unless there is an actual impact. Maybe it sucks down resources, or I spend money on those resources that I could spend on something else instead. So again, it all goes down to this tying together the business level with the infrastructure level. And the second aspect is this digital transformation is not from legacy apps to microservices. It is from legacy apps and web apps and a few new microservices-based apps and maybe a few serverless functions. It is a slow process where maybe I use an API gateway to extend the life of my legacy app, and I go gradually toward my goal, but at the same time, there's more and more layers that I'm building in where now all of a sudden, my microservices may be shared between a legacy app and a modern app, and maybe even a customer service. So keeping track of all of those things is the new challenge in monitoring. And there's a whole new breed of monitoring companies that we are seeing that is really taking this on, dynamically figuring out, oh, now this microservice belongs to this, and it depends on that external service. And here's how it all together fits into the, my shopping cart or whatever the relevant thing that I'm monitoring right now is that matters to my business. So it's really a piece-to-piece transition on the one hand, and that tying together from the top to the bottom on the other hand. That is a big challenge, and it will become a bigger challenge as customers adopt more and more services and resources from different public clouds.
So discovering, I want to make sure that, because it sounded interesting and I want to make sure I understood it correctly. So sort of helping people discover those relationships for these disparate systems, that becomes a very important part of this monitoring of how you want to do it, right? You want to have something that's going to help you not only just say, again, that, that person's pulse is off, but to be able to say the speaking sounds horrible. Tell me all the organs that the person has in them that are participating in that speech. And it starts at having a pulse and having some brain activity. And if you don't have those, well, then that probably explains why the talk isn't very exciting, right? And I've given talks like that. But being able to correlate what pieces are part of that puzzle, I imagine when you are in a big organization with lots of different teams, it's service orientation, you've got some loosely coupled systems. As you add more functionality, as you add more features, and people start to pull on those strings or call those API calls, being able to associate them with some outcome, I would imagine starts to become a lot harder.
Yeah, and it goes both ways, right? It goes from the executives. They don't care about the overall health of their IT. They care about the health of the relevant infrastructure. And at the bottom end, the infrastructure teams, they need to prioritize what they repair first, what they proactively maybe based on, we talk about proactive maintenance, but what should I really prioritize? What really has the biggest business impact today, right? They mostly don't know that, right? They refresh their servers, they put in new switches, they do certain other maintenance things, but the exact business impact and what kind of a capacity they are building for that company to become more competitive, that is very, very difficult to draw those lines. So yeah, it's top down and bottom up from my perspective.
Excellent. All right, Andreas, what are your thoughts on this? Tips?
Yeah, so actually, I wanted to add on what Torsten said at the end, because first, when you started, I wanted to jump in because obviously I'm representing one of the monitoring vendors where I believe over the last years we reinvented monitoring. Not only we, but all the other vendors in the space as well, because we changed our monitoring architecture to exactly solve the problems that you mentioned. And I think in the end, you said we see a lot of new players out there. We understand that applications nowadays need to be monitored differently. I think if you go to all the websites of the key APM players or other monitoring players in the market, they all sell you APM, end user monitoring, infrastructure monitoring. We all understand that only if you monitor the full stack, you actually can make the right decisions. And if you have end user monitoring, you know what is the business impact if something is slow and how many users are impacted. If you know the application, you know, is there an application issue? If you know the infrastructure, you can actually make sense out of where is my real root cause and where do I need to, which team do I need to get involved. So I think we as a monitoring market, and I'm talking about the vendors, we learned over the last couple of years that the new applications that we built that also need to interact with the traditional applications, they have changed, and so also monitoring had to adapt. And I think we did this. So I think we should not theoreticalize about this, because I think a lot of monitoring companies are there. We are providing solutions to these problems already. And that's what I wanted to say. I think another thing that we learned is, I mean, obviously the market, we're all moving towards more platform as a service, whether it is a Cloud Foundry, an OpenShift, Microsoft, they offers their stuff. I believe what we all try to do now is also getting into these platforms as services and baking monitoring in. And that actually also solves the problem. I think it was Mark earlier that said that, where he said, you know, as a developer, I may not monitor my environment. But actually, if you're building new apps on PaaS, if I'm a developer, I not only run my Docker container on my laptop, but I actually run it in a, let's say, Cloud Foundry environment. That is a dev environment, but still it is not only one container, but I can test it out, how it does it scale up and down. And if we have all of these different PaaS environments monitored correctly, and if we have the monitoring tools understanding the terminology, meaning we understand the tags that we use when we deploy something in a Cloud Foundry environment, we know this is the business component, this is the checkout component, this is whatever other component, then it's also easier to tie in all the monitoring data into your DevOps toolchain, because then I can say, hey, I just deployed something in my test environment or dev environment, I ran a load test, and now the monitoring data tells me on this particular component, I now see 50% more CPU consumption than before. Is this a good or a bad thing? Is this intentional or not intentional? And based on that, I can decide, do I move it further to the right, or do I keep it on the left and fix it? So I know this was like, you know, going in multiple different directions. What I want to say is, I believe monitoring tools, they grew up. We grew up over the last couple of years. We understand what it means to monitor enterprise stack and cloud stack and platform as a service. And I think we also learned that we need to well integrate into all the different platforms and tools that are out there. We need to understand which tests are executed. We need to get information about the test names, the transactions, because you want to get monitoring data for your individual tests. We are integrating in your tagging system, whether it's on Amazon, on Microsoft, or on all, you know, your PaaS environment, because you don't want to redo the whole thing again and educating the monitoring tool what type of components you want to monitor. You already educated and told your PaaS environment what components you deploy, so your monitoring tool can automatically pick this up. And I think I want to speak broadly about the whole industry. I think, I mean, we are also all representing different monitoring companies here on the call, at least some of us. I think we're all learned and evolved our products. And I also see it's great that we have new players on the market all the time that come up with new ideas, and also the open source space is amazing what's happening. But yeah, I think we've advanced a lot in the last couple of years, and I think we all know that monitoring is part of the DevOps pipeline and enabling all of the shift left and the shift right.
Great. So great information on tips for what to monitor, how, and why. I love it. Mark, what are your thoughts on tips for common use cases, what to monitor, how, and why?
So many things to say. I loved what Andreas just said, and also Andy's point about service monitoring. I think the key thing there is that what we're building today versus, say, 20 years ago when I started is systems of many scales, not just one scale, but many different scales. We have things happening at the microscopic scale, cluster scale, cloud scale, service scale, customer scale. These are different scales, and in a well-designed architecture, these scales tend to decouple from each other. What happens at one scale shouldn't strongly influence what happens at another, and we need to kind of find ways to separate those as different monitoring metrics. We figure out how to separate those metrics so we're understanding at what scale we're measuring. What I do see a lot in monitoring systems over the years, and I'm not talking about any of the new ones that have come out because I just don't know, but a common tendency is that we just try to collect as much data, as much low-level data as we can, typically from logs. And what you get from logs, of course, is basically what people have graced you with by virtue of their code. You may not see very much. And then we've got the standard things that you can get from the kernel, which also aren't strongly correlated with the things happening in the performance behavioral level. So pulling out a high-level picture from low-level masses and masses of data is incredibly difficult problem. Way back in the 90s, I remember Paul's point about the black box. I remember '97 when I started looking at this, my friend Marcus Ranum started Network Flight Recorder. This was about intrusion detection, but that's another story. But what I got interested in around that time was applying machine learning to this issue of monitoring to try to figure out how we could compress the data down to the point where we're only looking at relevant changes, anomalies, if you like. And by anomalies, I don't mean intrusion detection on anomalies, which was the rage then, but how we can really filter out the noise that we don't need to see and only see relevant information, because scaling that information to be consumed by a developer, an operations person, a systems level person, a service level person, incredibly hard problem. And we tend to be blinded by data. And of course, the industry narrative has been big data. We must collect big data because we have all the disk and it's so cheap. But they don't think about the skills needed to wade through that data post hoc, or the idea that that simply doesn't scale when you scale it up to a large size. The latest example of this is IoT, right, where people have been saying, oh, we have the biggest data center on the planet and the fattest network pipe on the planet. We can suck all of that IoT data into our data center and handle it for you. And it lasted a couple of months, and now they're not saying that anymore. So I think the big challenge is in scaling the amount and relevance of the data coming out. Going back to the pulse argument, where we tend to collect a lot of meaningless data and try to abstract the meaning later. But what I think we should be doing is what AI is doing, which is building smart sensors that detect something specific instead of something generic. And your eye is this wonderful thing that evolution allowed to measure movement and faces. Even faces can be recognized by the technology before it reaches the higher level of the brain. Stuff like that pre-processing of data before just blindly collecting it all in a big lump. I think that's where a lot of the challenge of monitoring is today, because our software is becoming more sophisticated. That means our semantics are becoming more sophisticated, and therefore our monitoring needs to become equally sophisticated to give meaningful feedback.
Very good. All right. Very interesting. Paul, you're the last one who hasn't spoken on this topic. I'm assuming that there might be other people who want to comment on some of the comments that have been made, and we'll get to that after you're done.
Yeah, no, I was going to say, so I want to go back to Mark's comment about big data. And again, I think it's a great comment because big data is not the same as big information. And it's funny that everybody's talking big data, but nobody's really talking like big information, that distinction between data information and information again. When I look at, what I'm going to say for what to monitor, how and why. For me, it's always the operational aspect, right? So the people in the system, what are the human factors at play? And so, I go back to one of the best ways to do that is chat ops. And I think, I don't know if we've had a C9, D9 on chat ops, but this idea that we have an ongoing recording of all of our work. And what's great about that, Sam is telling me that you did do one. So go back and find that episode, because you're going to find a lot of people talking about basically systems that create the black box for you and allow you to, when there's a problem, one of the biggest uses of monitoring, go back and actually have a deeper understanding of that. And I hate to harp on aviation, but it's such a great field. Because there's so many parallels of lessons that they learned with, automation. They learned a bunch of things in the 90s that we're just starting to learn. And if you look at some of the big aviation accidents, actually in the US, or near accidents in the past 5 years, that crash in Buffalo, New York, that took a number of lives. And also the very recent one in San Francisco, where that Air Canada plane almost landed on the taxiway. Both of those investigations focused on human factors. The pilots in the Buffalo crash had colds and didn't have a lot of sleep. The Air Canada one, they're still figuring that's a weird one, but I know they landed at like 12:30 at night, right? And so one of the big questions that we see a lot of times from an operational perspective is, who was on call and how long were they on call, right? And I once talked to someone who worked for a small company, and he had been literally on call 24/7 for 2 years straight because he was the only ops person, right? So if you're looking again at your entire system and you keep having problems, and it's like, we do user monitoring, we do app monitoring, we do infrastructure monitoring, we still have an outage, or still keep having outages that follow this pattern of scheduled maintenance goes awry. Well, maybe it's because your IT staff has been on call constantly for 2 years straight without a break, right?
So what you're saying, Paul, is it's the IT staff's fault, so you should fire them all.
That's exactly what I'm saying. Blame all of them. Yeah, no,
Okay.
no. But that's the point. There's this aspect of monitoring, and it sounds sort of 1984-esque when you say, like, how do you monitor your ops staff or your operations or the operational aspect? And I don't mean it like that. It's sort of how do you all of that operational nature of all the people. And with DevOps, we see, all of that shifting left. So developers are carrying pagers and things like that. So it's how do you sort of get insight into the human performance aspect, not just the application performance. And again, I think, Andreas was saying there's lots of great tools, the user level, app level, infrastructure level, but there's still like a operational bit that I think we're just starting. And there's lots of really interesting conversations at the vendor level of, like, how do we bring that in? And you see a lot of those conversations too happening at the incident management tool space. So like a VictorOps and a Splunk, a PagerDuty, they're trying to figure out, well, how do we integrate that with the monitoring and then also the operational part? So a lot of interesting meat there, and I think we're going to see a lot more of that over in the next few years, specifically as it relates to monitoring.
Very cool. Andy, Mann, you had something you wanted to add?
I do, because I love what Paul's talking about. It just reminded me, I visited with a customer in Australia a short while ago, and there was the director of development transitioning into a DevOps mode. And one of his MBOs, one of his KPIs was actually team happiness. So we actually worked on a bunch of stuff, right? So we worked on mapping out, so we looked into the data coming out of their GitHub to see who was checking in code, what time of day. So a 3 a.m. check-in on a Sunday morning could be normal, or it could be a work-life balance issue. We looked into getting data out of HR systems to see how many people were taking sick days, work from home days, some indicators as to whether that might be maybe a toxic environment. If people work from home a lot and they don't want to go and work with their peers, that's a problem, maybe. The other thing, Mark mentioned IoT, and this was really cool. We were just talking about some stuff. We came across the idea of the happy face, smiley face, the happy face, frowny face buttons. So IoT buttons, and he's now installed those buttons on his developer rooms every time they have a meeting. It's anonymized because it's just a thumbs up, thumbs down. But whenever they walk out of their meeting, they just hit a button and say whether it was a good meeting, bad meeting. So this manager is starting to track now the happiness of his people in metrics. Now, you can't get everything from that. You've got to have personal conversations and stuff. But yeah, as Paul was saying, time on call, late night calls, work from home days, all of this stuff is measurable and monitorable, and you can absolutely bring the monitoring.
Very interesting. I love it. That's basically, again, you're bringing it up to a higher level. You're looking at the full system as opposed to just focusing on infrastructure, CPU count.
Well, and one thing I'll mention real briefly, you'll hear this phrase a lot, this term socio-technical system, right? And we talk a lot about—
I hear that all the time.
Right.
I hear it all the time.
Yeah, we talk a lot about technical systems. This is the socio part, right? The socio part of the socio-technical system.
Excellent. All right. I was trying to make a joke and I interrupted your whole thing. I'm sorry, Paul. That's what I do. Anders, take us home on this topic and then we'll jump to the next one.
Yeah, I mean, hard to add a lot of good content to that discussion because a lot of good stuff in there. I think interesting comments by Mark there about sort of the visual processing and recognizing faces before we hit the higher levels of the brain. I mean, I think a lot of what we're trying to do here is to surface patterns. Try to sort of find that tall blade of grass that's out of place, that means something, typically bad. We're looking for something that's off. And that's very difficult to do. I mean, as we're saying, we've got, more data than we know what to do with. How do we turn it into information? How do we turn that into knowledge? Very, very difficult. It's easy to do kind of all the cross-cutting concerns, packet latency and loss and, drive space and, kind of all the mundane kinds of things. I think what's more kind of valuable and important, well, as valuable, but also important is, what about the semantic level type stuff of, where are we in terms of API monitoring, or our API calls functioning the way they're supposed to, and kind of higher up the stack in terms of, are we getting, the outcomes that we want, the click-throughs and all of those kinds of things. So I think getting all of these things into one pane of glass will be very interesting as we move forward in the next couple of years. To where we can, maybe start to get a little bit more machine learning or other types of help on finding that, the tall blade of grass that needs to be chopped down, and do a little bit more pattern recognition. Because a lot of times what we're doing is, we're displaying, on huge monitors all these graphs, and all we're really looking for is a knee in the graph that we didn't expect. Well, we don't really need the graph to be there the whole time, right? I mean, that's a pretty easy thing to sort of find and just turn the red light on when it needs to be on. But it's tricky. It's definitely an interesting field to be engaged in.
All right, and so let's wrap up this episode with what happens if things go wrong when you're using your monitoring solution and you find something that's not quite right. What does that look like, and how do you sort of use the monitoring tools to help you address those things? How is monitoring helpful there? And let's start with, I'll start with Paul this time, since I haven't started with you yet. Your face is up when I come back.
When things go wrong, that goes right into that sort of incident operational space that I've been talking about the whole episode. And so there's a lot that we could talk about there. I'm actually going to turn this on its head a little bit because I sort of missed the first part of the episode where we talked about prerequisites. And I would make the argument, actually, that if things are going wrong a lot of the time and you think you have monitoring and yet things are still going wrong, I swear this was not a plant by Mark, but his book, In Search of Certainty, really is awesome. It's an awesome book. It's a great book. And here's the thing, though. I talk to clients all the time, and I tell them your large-scale infrastructure has more in common with quantum physics than it does with the laptops that's sitting on your lap. And people look at me like I'm crazy and insane. I'm like, no. There's a guy who wrote a book, and the book is easy to read. It's great, and it explains what I'm trying to explain to you. So the point, and explains it much better than I probably just explained it. So my point is that if you think you have monitoring and you keep running into problems, the problem may actually be how you as an engineer or as an organization think about the monitoring space. And if you want to really understand all of that, just go get a copy of In Search of Certainty and read it. It's great bedtime reading. It will keep you engaged. And I think it really helps frame some of the things that we're talking about. Again, when we talk about that analogy about the pulse and why is the speech bad and all of those concepts, there's a lot of really good analogies. And this book not only explains that, but brings all the science in and can be really helpful if you're having trouble in how you think about monitoring. It can help with that. Super useful.
Excellent. Mark, I'm going to let you go next.
Wow. Well, thanks, Paul. That was a wonderful plug for my book. Of course, when things go wrong, you need to know where your exits are, and make sure you have a copy of my book because it acts as a flotation device. But more seriously, one thing that's kind of interesting, and actually a story that I told in that book, was when simple things go wrong, it's no problem, right? It's some kind of quick fix. Hopefully, if your monitoring is tuned into routine issues, it's fairly straightforward. People can figure it out. It's those pathological problems that you really, when something systemic happens that you just couldn't possibly have understood, an interaction of things that is beyond comprehension. Those are the really the difficult issues. And the first thing I would say is don't try to roll back, because the immediate instinct people have is to try to undo what they did and get back to a working state, which of course, first of all, eliminates the possibility of diagnosing the problem.
Right.
But also you never get back to that original state, and you may have just made things worse by doing this. This happened to me a couple of times. I ended up on a 12-hour call to a client some years ago, and it was this most bizarre sequence of interactions between technologies that we really barely knew were under the covers. A queuing issue, actually. A lot of things in systems tend to be queuing issues, but finding the right queue is the hard part. And again, if we could learn from those mistakes, so not just machine learning at the recognizing patterns at the low level, but if we could also write up those incidents, to Paul's point about human factors, systemic factors, we should really try to analyze them, come up with models, because you're hypothesizing about causes and effects. Of course, this is where humans are indispensable, because it's that human experience which cannot be programmed into any kind of automated system that will eventually enable you to see the thing that is beyond comprehension. There's a great quote by Picasso, I think it's on my Twitter feed: "Art is the lie that allows you to see reality." You know, it's by projecting ideas, hypotheses, imagery that allow us to see something totally unexpected in a flash of insight, which is how we can often diagnose those pathological errors that are going wrong. So, you know, with your flotation device under your arm, don't forget to use your head, because you can't possibly rely on technology to solve all of those issues. And don't roll back straight away.
Don't roll back. I love it. All right, very good. Andreas, what are your thoughts here?
I just want to add what the previous two guys said. I think the worst thing we can do is if we have a problem and then we have the superhero who is trying to fix it and never shares what he did with his peers, right? That's basically what you just said, because then you become like, I don't remember the name of the character in the DevOps handbook.
Brent.
Yeah, exactly, right. So I think it's key that we share what we learn from failure, and then trying to figure out how we can automate the detection of that particular pattern by shifting it left, by adding a new test, by looking at the same metric early in the pipeline, preventing it. And then maybe making also, if we have any AI, any machine learning in production, make the AI aware of this problem, so that the next time it's not as hard anymore for whoever needs to then look at the problem to identify, hey, this is this problem, and we solved it before. Now I know how to do it.
Excellent. Thank you, Andreas. Andi?
Yeah, I'm just going to throw out, when you talk about triage and troubleshooting and something's already going wrong, I'm just going to throw out a couple of words in defense of big data at this point. Because get to this point of doing triage and troubleshooting, you didn't originally collect, right? I mean, if you've ever been, well, we've all been in troubleshooting situations, and that one morsel of information which you decided was not important, all of a sudden becomes absolutely critical. So, you know, to an extent, it's true, storage is cheap. So collecting all of the data that you might need to be able to triage and pinpoint problems. And, you know, certainly Paul will jump down my throat if I start to talk about root causes. But if we start to find a bit more to Andreas's point, things that have gone wrong multiple times, then you need to be able to correlate all the data. It could be something on the network, it could be on an end device, it could be on the application, it could be a server, it could be a cloud problem, an API problem, it could be wire, all sorts of stuff could be going wrong. Point of triage and troubleshooting that I think that big data starts to really come into its own, because you do find the needle in the haystack. Maybe, you know, you obviously need to balance cost effectiveness of storage and all that sort of stuff. But again, in defense of big data, you only miss it when you forgot to collect it in the first place.
I think a product that would be great for monitoring folks would be a time machine, so that you could go back and monitor the stuff that you forgot to monitor, because that would be, I mean, you'd have the market right there. Torsten, Thoughts on this?
I think, yeah, I think actually time machine, that's a very good point. And short of a time machine is using big data across enterprise boundaries, right? We see more and more vendors at least working on it, and some of them have it already, even though it's a little bit opaque in terms of how far it goes and what it does. But operations, management, and root cause analytics that learns across organizational boundaries, where all of those things that are hidden, the hidden correlations, right? You have no idea somebody uses the accounting system over in Chicago, and at the same time, for some reason, my shopping cart slows down. Nobody would ever see this as a correlation, right? Nobody could ever draw the lines between that because the lines may not be straightforward. There may be something organizational, there may be a bunch of intervening factors, but if you cross-correlate that across different enterprises and learn from this, from all of those incidents, you will discover a lot of things that you can use to make your customers, basically to tell your customers, look, this is not a time machine, but it will prevent a lot of issues that you cannot anticipate based on collective learning. That to me is a big next frontier, right? We see for VMware has these health services that they are timidly rolling out, and there's a lot of other vendors. Hopefully, I'm not insulting anybody on the call that are that are working on this kind of technology, where you really are accelerating root cause analytics, and you are targeting exactly what you're monitoring, right? You have an eye, a sensor that specifically looks for certain constellation of factors, but that's not a constellation that makes rational sense, but it's a constellation somewhere buried in big data across a lot of different companies. So that to me is the exciting part, right? The next piece of machine learning, make some decisions in the machine, cross-correlate data, and increase operational stability, right? Decrease the number of putting out fires, or fires that have to be put out.
Provide pre-chewed information, basically, right, for the humans to be able to take some action on. I think that's super good. So, Anders, bring us home, pal.
Sure. So, I think, troubleshooting and fixing the problem, and I think that, the dimension that we add there is time. Now we've got time pressure. Fix it, it's broken, we're losing money now. That becomes a human factors issue. And probably like Paul, I'm a little bit of an aviation nerd, and I actually read NTSB accident reports, and it's fascinating how many problems are caused by what we do when we're under pressure. And aviation tries to reduce that complexity by having checklists for very specific scenarios, and trying to think through all the things that can go wrong, those kinds of things. And I agree with Paul. I think there's a lot that we can learn as an industry from that, just like we learn from manufacturing about lean and all of those kinds of things. So I think when it comes to actually fixing the problem, once monitoring brings some sort of bell, it's very much at that point a foot race, and then it's a little bit of a different thing, because now it's people involved trying to fix things under pressure, and that's that makes it more interesting. But if you monitor starting before production, then a lot more people will be exposed to that information. So maybe that's one of the ways that we can help make that work a little bit better.
Very good. Well, an amazing panel of super smart people. I can't get the picture now of Torsten's shopping cart slowing down because somebody was entering something into an accounts receivable. I have just the image to share with you guys. Look for it on Twitter when we're done with the episode. Thanks all for joining, and we'll see you all on the next continuous discussions.